Hello, and welcome to another session of What the. See, I'm already making what the mistakes. I did make a mistake in the video previous to this in regards to what a particle and element is. We're going to go into those circumstances in regards to organic chemistry and what is determined as organic. Because the circumstances that currently exist, there are mistakes. Those mistakes stem from labeling all organic chemistry as a carbon-based isomer, which is not true, because there is living matter that exists, and that living matter is constituted from DNA. And DNA, well, that has nucleotides. Nucleotides are nitrogen isomers that coexist with one another. And understanding those circumstances, because, well, we know that if you have carbon, oxygen, hydrogen, and nitrogen, that is proteins, and proteins are what we ingest to promote cellular metabolism. Anyway, and there's nitrogen. So we know that nitrogen is the fundamental isomer platform for living matter. Therefore, I have stated this time and time again, and they determine carbon to be the isomer because when carbon starts to decay, they say it decays into nitrogen, which is a mistake. Carbon does not decay into nitrogen. Carbon sublimates because it's an element, and it is constituted of charged particles. We all know that because of periodic table of elements. It sublimates and it goes from a solid into a gas, and that's the particles dissipating. So it doesn't decay, it sublimates. The element of carbon sublimates, and then you have left nitrogen. And nitrogen is the fundamental isomers for living organisms. So how can we say that carbon is a living organism? It is not. It's not a living organism. It's and they call it organic, and it's not even, or it's, yeah. And then they want to label nitrogen as, not even the base isomer for living organisms. And it goes into a whole convoluted circumstance of why is carbon even included in that circumstance. So, anyway, my whole argument is the carbon versus nitrogen argument for organic chemistry. And nitrogen should be labeled organic, carbon should be labeled inorganic, and then at that point it would make more sense. But you have to go into a circumstance of plant or human biology where we know there's body chemistry that exists, and we know that gases exist inside our body, and we know that all this fluid in our body undergoes a transition into gases, and then it transitions from those gases to inside the cell, and then they're digested, and then the polarity of the cell differs between sodium potassium chloride, the salts that exist inside the cell, which make the cell negative. And then the negative interior of the cell is more negative than the extracellular fluid outside the cell. And then a rosetta of proteins align themselves outside the cell because of the polarity inside the cell being more negative. And then channels or gates are opened, and then the proteins enter the cell, and then metabolism occurs, and then the cell becomes, well, less negative, I think at positive 30 millivolts, and then the extracellular fluid is more negative than the positive, and then these channels or gates are opened again, and then the exchange of ions occurs again. So it's just rapid polarization and depolarization of the cell, and these circumstances are all about the proteins, which have a nitrogen-based isomer associated with it. So, and we know that, after so much amount of time, then the cell undergoes mitosis and splits into two cells. Carbohydrates, which are lacking nitrogen, are not building blocks. So we know that. It's not a building block for cellular metabolism. So it's basically short-term energy, and so on and so forth. So anyway, you go into the ATP circumstance and Krebs cycle and all that other stuff. But you need proteins. If you have just carbohydrates, well, you start burning muscle after a while, and so on, and you'll burn stored fat, and so on and so forth. So, anyway, and that's my whole argument. Carbon is not a building block, and so how can it be organic? I mean, I can go on and on about why carbon is not a building block comparative to how nitrogen-based isomers create proteins and so on and so forth, polypeptides and all that other good stuff, because of the living organisms that exist that constitute these circumstances, which are precursors to proteins, which are nitrogen-based isomers. Anyway, this has been another session of What the